Hi viewers, welcome to my channel. In this lecture, we'll discuss Databricks or Spark ecosystem. Uh, Spark architecture or Databricks architecture internal working mechanism already we have seen in previous video. So if not watched, then again you can go through my playlist and you can go through the internal architecture. See, Spark like Hadoop, Databricks also has ecosystem. Hadoop main processing engine is MapReduce. Main algorithm is MapReduce. Okay, MapReduce you will write using Java. So using Java, if you develop the project, it will take more time for the development because everything you need to write a mapper program, then reducer program, then driver class like that. For every program, we need to write three programs. Every task, we need to write three programs. Okay, and also MapReducer, it will be execution is very slow because intermediate results will be returned to the disk. Okay, there are a lot of read writes will be there, so it is slow MapReduce. Okay, and also to provide interactive querying purpose, they have uh, they have developed a Hive. Okay, Hive is developed from the Facebook. Facebook company has developed Hive on top of MapReduce. Okay, so if you write Hive script, it is similar to a database. In database, how we will write SQL queries? Here, Hive queries we will write. We called as a HQL, Hive query language. If you write HQL query, internally again it will convert to the MapReduce program, then it will execute. So, but for the developer, it will we will feel like a SQL kind of interface. That's how we will development time will we can save. Okay, and in the same way, Spark also main Spark engine is a main processing layer is Spark core. That is Databricks. That is nothing but a Spark core. Spark core is a main processing engine similar to MapReduce, and the data abstraction in Spark or Databricks is a in Spark core is a RDD, Resilient Distribution Data Set. Spark or Databricks will support four languages. Databricks will support four languages: Scala, Python, SQL, and R. If you want to work in as a Databricks developer or a Spark developer, you should know either one language. Okay, Scala, Python, SQL, and R. Data abstraction is a RTD. Once you loaded some data, okay, so for example, text file if you load it will be by default it will be RDD. Okay, so if you write develop the project in RDD, it's not that much efficient. There is no optimization techniques. The code will be, looks like a programming language. Okay, so development will take time. It will take for the developer. So what they in the similar to improve the performance for MapReduce, how they provided a ecosystem, Hadoop ecosystem, Hive, big scoop like that. For Spark Core also, they have provided a SQL kind of interface that is using a SQL engine. One layer on Spark Core, one more layer is there that is an SQL engine. SQL engine has catalyst optimizer. Okay. For example, in a Databricks SQL approach, if you write some Databricks SQL query internally, first that query will be that logical plan, physical plan, everything. After that, the query will be uh, converted to the Spark core. That is nothing but RDD. Then RDD will convert that code to Java bytecode, and then that Java bytecode will be executed. Okay, so that catalyst optimizer will take care of converting that SQL query to the RDD. Okay, that is Java bytecode. This Tungsten project take care of the memory management. For execution and all, we need a memory, right? That memory management, Tungsten will take care. These two projects will give the optimization to the Spark engine, SQL engine. That's why Spark SQL and other ecosystem tools are very fast when compared to the Spark core in terms of execution. Because due to this catalyst optimizer and tungsten. That's why for the projects, instead of RDDs, we will use Spark SQL. Okay, like Spark SQL internally will have SQL engine. So data abstraction in Spark SQL is data frames or data sets. In Python, Databricks with Python, we don't have data sets. In Scala, we have data sets. If you use Python as a language, you cannot see the data sets. Only we have data frames. In Spark Core, RDDs is a database. Storage level is RDD. In the Spark SQL, okay, not only in Spark SQL, Spark Streaming, Spark Library, Spark Graphics, all these ecosystem libraries, we will create data frames only. Again, if you execute the data frame internally, that SQL engine will convert that to the RDD. Okay. Again, RDD will be main processing engine here. RDD will be processed by the Spark core. Okay, it will convert to the Java bytecode. Then that Java bytecode will be executed on a JVM. Okay, so in SQL, how we'll we'll store data in tables. Similarly, Spark core we have RDDs. Spark SQL we have data frames. Okay, Spark SQL usually we will use in projects to implement Databricks code. We will write data frames only. Okay, that's how those who know the SQL and syntaxes, they can easily work on Databricks once they understand the internal working of Databricks. If your data is unstructured data, you can use RTDs. Okay, RTDs has a different type of transformations and actions to handle unstructured data. Okay, your data is a structured data like a table or Excel sheet, CSV file, Parquet file. Then you can process that using Spark SQL. Again, in Spark SQL, we have SQL approach and data frame approach. That we'll see in upcoming videos. Your data is a streaming data, like continuously data is coming, like a Twitter sentiment analysis from Twitter and this Netflix, all these streaming platforms, continuously data will be coming. If you want to handle such type of streaming data, we have a module in Spark or Databricks to handle streaming data, that is Spark streaming. Here Kafka we can integrate. Okay, we can use Kafka as a broker in a Spark streaming. That we can see in a few while discussing streaming data. Okay, then Databricks we have machine learning, right? So MLib we have machine learning libraries also. We can uh, uh, we have a machine learning library module to work on data science projects. All machine learning libraries available in this module. If you are working on that machine learning data science projects, you can import and you can work. Okay. So internally, all these four ecosystem will use a Spark SQL engine. Okay. And the next graphics. This is also data science related module only. For internally, it will facilitate. These are all the ecosystem modules using which we can process the data. Again, that all these Spark streaming, Spark SQL, machine learning library, everything you will be developing in a SQL kind of interface only. But once you execute that SQL kind of the SQL approach or data frame approach, that code will be converted into Java bytecode using this SQL engine, and that Java bytecode will be executed on the JVMs. Okay, because Databricks is developed using Scala. Scala is nothing but Scala internally uses JDK Java 1.8. That's how it has the so internal execution process similar to the Java. Okay, this is briefly about Databricks ecosystem. First, main layer is a Spark Core processing engine, similar to MapReduce. Spark SQL similar to Hive. Okay, so if you have any doubts, you can comment. You can provide your feedback on your comments. Okay, I will provide if any. I will clarify your doubts if you have any.